In this video, I'm going to show you how to simplify a square root or a radical when there's a negative number on the inside and this results in an imaginary number. So an imaginary number, or I comes from the square root of -1. So typically we don't think of square roots as negatives being possible because when we have the positive square root of 9, then this is really the answer is positive or -3 because 3 times 3 is 9. Or -3 times itself is also 9 because a negative times a negative is still a positive. Now when we go to simplify a square root that has a negative on the inside, we can't do this without imaginary numbers because a negative number comes from a positive times a negative. So if we can break this into -1 times 9 to be -9, then I can simplify this radical by going ahead and square rooting -1, and I know the square root of -1, that is this value up here, which is I. So now I have I times the square root of 9, and then the square root of 9 is positive or -3, and so we write it as positive or -3i. Sometimes you only need the positive square root, just depending on what you're working on. And that's sometimes called the principal square root if you see that in directions. All right, number 2, this would be -1 times 100, so I can square root -1, it is I. Now I have the square root of 100, and the square root of 100 is positive or -10. So I have positive or -10i. All right, number 3, you're getting the gist. You might even be able to skip this step of writing it out as -1 times 8. I know the square root of -1 is I, and I'm left with the square root of 8. Well, square root of 8 is not a perfect square, and when this happens, we need to break it down. Some people do this by breaking it down by only dividing it by perfect squares. Some people do this by using a factor tree. My students typically are better with the factor tree method, so that is what I'm going to use here. So I'm going to break 8 into anything that multiplies to be 8 besides 1 in itself. And so I'm thinking of 2 times 4. 2 is prime, so I bring it down. I'm trying to create what's called a prime factorization, which means all the things that we end up with are prime numbers multiplying each other. So I'm going to break 4 into 2 times 2. All right, so 2 times 2 times 2 is 8. That's why this is the prime factorization. I have a group of 2's here. 2 times 2 is really 4, so I can take that out by square rooting it. The square root of 4 is 2. So anytime you have a group of a pair of 2 numbers, you can bring out just one of them on the outside, and whatever is left is what is written on the inside. So this is where this 2 came from. It's really the square root of 2 times 2, which is 2. All right, let's keep going. Number 4 is a little bit more challenging. Oops, and I forgot to do my positive or negative. Number 4 is a little bit more challenging. The number is bigger. It's not a perfect square. So I'm going to go ahead and jump to writing this as I square root 72 because I know that I can take out the square root of -1. And then I'm going to start breaking 72 down. Any even number can be divided by 2. If you can think of bigger numbers that go into 72, then that also works. So I'm just going to do 2 times 36, and then I'm going to bring down my 2, and I have 6 times 6 is 36. Now, I'm going to show you what would happen if you didn't notice that that was already a pair of numbers. So you could stop right here and write this as positive or -6i square root 2. You could, but I'm going to show you how it ends up being the same. All right, so I'm going to keep breaking it down until all my numbers are prime. This is a 2, this is 2 times 3, this is another 2 times 3, and if I multiply 2 times 2 times 3 times 2 times 3, I end up with the 72 that I started with. I'm going to circle any pairs of numbers that I have. Here's a pair of 2's, here's a pair of 3's. So 1, 2 comes out on the outside, 1, 3 comes out on the outside. The I is already there, and there is a 2 left on the inside. I do need my positive or negative. 2 times 3 is 6i square root 2, and that is exactly what I had up at this level. If I had noticed those 6's, I could have gone ahead and done it then. Okay, number 5. Again, I'm going to start by writing this as I square root 252, and then I'm going to divide 252 by some numbers. Now, I'm going to go ahead and jump to bigger numbers because I don't want to deal with the length of my tree if I'm dividing by 2 every time, but you're allowed to do that. I just use my calculator and I see that 4 times 63 is 252. And then I'm going to keep breaking this down. This is 2 times 2. 63 is 7 times 9. And so I have 7 times 9 here. And then I'm going to bring down my 2, bring down my 2, bring down my 7. And then 9 is 3 times 3. So when the number was prime, I brought it down. When it's not, I keep breaking it down. I now have a pair of 2s and a pair of 3s. So I'm going to have 1, 2 coming out, 1, 3 coming out, oops, and my 7 on the inside. I forgot my I, there it is, forgot my plus or minus. So now I have plus or minus 2 times 3 that came out is really 6, I square root 7. Hope this helps.